The following program is made possible by the friends and partners of Creation Today. Welcome to the Creation Today show, where we bring together interviews with experts and solid Bible teaching. Your co-hosts, Eric Hovind and Paul Taylor, affirm the ultimate authority of God's Word, the truth of creation, and why it matters to you.
What we're going to be learning about today is how life actually evolved from non-living chemicals in the ocean billions and billions of years ago.
Eureka!
No, urea.
Oh, urea. P-tax.
Yes.
Well, welcome to the Creation Today show. Thank you guys for joining us from around the world, whether you're viewing it on our website, creationtoday.org, or one of the many networks around the world brave enough to air this controversial information. Paul and I have been this is week number 3 of a 4-week series on the origin of life, and I'm finding this fascinating.
It's amazing, isn't it, really, how many different ideas people have on where life came from. Evolutionists have a number of different ideas on where life came from, and in some cases, we found some of them pretty amusing, actually.
It is amusing, because when you look at the fact that, okay, they had problems, and we're talking today, by the way, about how did life evolve right here on Earth? How do they think that happened? But because that was a problem, we first had to address how did the fact that some people think it evolved on Mars and what's going on there. And why did they do that again? Why did they take it off of planet Earth and take it to Mars?
Well, it's an interesting problem, okay? First of all, you've probably heard that people tend to believe that life had to evolve in a reducing atmosphere. There couldn't have been any oxygen around. But then some research more recently has suggested that a particular compound was needed in order for these chemicals to evolve in this way. And this particular compound was a compound of the element molybdenum, and it was in a high oxidation state. So clearly, since molybdenum can demonstrate several different oxidation states, it will only be in a high oxidation state in the presence of oxygen.
Clearly.
Yeah.
Clearly.
It will not be a high oxidation state in the presence of a reducing atmosphere. There it will have a low oxidation state. So they have already decided that Earth's early atmosphere has to be reducing atmosphere, no oxygen. Therefore, the obvious answer is that life developed on Mars.
I'm telling you, just simply moving the problem to another planet. Then they got a problem of getting that, how do you get the life from Mars to here? But anyway, we covered that in show
floated across space. It's just incredible, some of these ideas that they have. The idea that life could have just floated across space. And it's fascinating, the way that they use the planet Mars, because on a slightly different topic, that they believe that Mars was once completely covered in water. And they even call that the sort of Noah flood epoch on Mars. But they won't believe there was ever such a thing on Earth.
It is mind-blowing that they can look at it there and say it happened, but look at it here and say it didn't.
Amazing.
By the way, show number 1 is on our website, creationtoday.org. If you didn't get a chance to check that out, you can go watch the show there. Okay, then they said, okay, well, if it didn't evolve on Mars, Richard Dawkins, of course, in Expelled, has brought out this new idea. Well, it's not really new. It's been around for a while, but he is a proponent of the idea of panspermia.
Yes.
Is it possible, Paul, that aliens are what seeded planet Earth with life?
I'm not really sure how strongly Richard Dawkins holds that idea. I think it was just sort of he was throwing it out there really because he was under pressure, and it just shows really the paucity of his position that he simply had to come out with this idea that life couldn't have evolved on Earth because there isn't sufficient time. The 4.6 billion years that they think the Earth has been around is simply not long enough for the type of evolution that they believe in, and therefore it must have evolved somewhere else and floated across space. So once again, it doesn't really explain anything. They just shift the problem somewhere else. But of course, this is the big deal, because you ask a standard evolutionist how inorganic molecules, non-living molecules got together and formed a cell, and they say, well, evolution doesn't talk about that.
Exactly. They try to say that evolution only deals with life once it's here. And that, again, is just shifting the problem. Either way, you got to get it here. And we know that evolution really does, in the whole worldview, in the whole scheme of things, it really does try to solve from Big Bang all the way to today, from beginning to now, it really does try to answer those questions. So when they say it doesn't, I call them chicken. I'm like, you guys are just trying to ignore the fact that you got no clue, and it's blind faith is what it is. That's what's really going on.
It is, and it's really just a much more sophisticated idea, version of the spontaneous generation idea, really, isn't it?
Yeah, it really is. That's
the idea that life just appears by itself. People used to believe that because they had some evidence. You leave a piece of meat out and maggots just appear in it by itself.
Magically.
But of course, we now know from experiments that were done that isn't the case. Of course, it's because of flies coming along.
Exactly. Louis Pasteur and Francisco Redi disproved spontaneous generation. That doesn't happen. Okay, here's something that you might hear on a regular basis out there in the news or in scientific articles. If you read those, they're always talking about organic compounds. You know what?
Yes.
We might have found organic compounds. I remember reading a couple months ago. Might have found organic compounds on Pluto. Woohoo!
Yeah.
Well, what exactly do they mean by organic compounds?
Yes.
Paul, this is something you and I were discussing.
Absolutely. I mean, they assume that this means that there must be some life. If there's an organic compound, then it's come from life. But that's not the case.
Yeah, go through the history that you were teaching me about that. Where the idea of organic compounds
You see,
came
obviously the word organic is to do with life. And at one time, an organic compound would have been a chemical that was found in living things. And they used to believe that a chemical found in living things could not possibly be synthesized by an inorganic method.
In other words, it had to come from life in order to be produced.
But eventually one compound was, and many, many more have been now. And the first compound that was actually synthesized...
This is kind of embarrassing, guys. I'm sorry. We're just going to talk about it. We're not going to touch on the subject for long. Just going to talk about this. The first one that was synthesized was...
Urea.
Eureka.
No, urea.
Oh, urea.
And it's found in urine.
Wow. We've got to talk about that today.
We have indeed. Now, urea, the main constituent of urine, has been an important industrial chemical for actually millennia. It's used in explosives, it's used in textiles, it's used in fertilizers. One of the most important ingredients, for example, in the manufacture of leather.
So tell us how they got this before they synthesized it.
Well, they gave people pots and bought the resulting mixture from them.
So you used to be able to sell your byproduct of drinking lots of liquid.
There was a thriving market in this in the northeast of England where they made as much money from that as they did from digging coal up from the ground.
Whoa!
And
buying people's waste.
Yeah, but even earlier than that, in the Roman Empire, it was a very valuable product. So valuable that the Roman Emperor actually put a tax on it. Known as known as the P tax.
The P tax. Oh my goodness. I'm blown away, but history is very interesting. And if you got to have it and you can't synthesize it, hey, that's the only way to get it.
You know, by the 19th century, demand was exceeding supply. People couldn't produce enough of it.
Drink more water. Drink more water.
Well, that would dilute it, you see. Then you wouldn't make any more of the compound. Well, in 1828, a scientist called Frederick Wöhler developed a synthetic method of making the molecule. And he made it from inorganic ingredients. Lead cyanate, heated up, and gradually decays into ammonia. And you can see the equation on the screen. But eventually, one of the main products of that is urea. So this was an organic compound, a compound from living things, but it had been made by an inorganic means, which meant they had to widen the definition of the word organic so that it now no longer means a compound only found in a living thing. It basically means a compound that contains carbon and hydrogen and maybe other things as well, but at least those two.
Wow, that's interesting. So now they've got the ability to do that. All right, well, when we come back, we're going to take a short break. When we come back, I want to continue this whole idea of how did life evolve on Earth, if that really happened. So stay tuned. We'll talk about that. At 21 years old, I was a self-professed Christian, but I didn't know God. I had been raised in church and in a Christian home and Christian school and enrolled in a Christian college. I was around church and religion literally all my life. So why didn't I know God? growing up in a Christian home, I got really good at pretending to be a Christian. I didn't really have a desire for righteousness. Instead, the only thing I pursued was trying to make everybody think that I was a good person and give the perception that I had Christ as my Savior. I just wanted to look good among my friends.
Welcome back. You're watching the Creation Today show with me, Paul Taylor, and with Eric Hovind. And before the break, Eric, we were just talking about, shall we put it delicately?
The P-tax.
Yes, and a compound which was an organic compound, that is to say urea, and thought being a compound found in nature that you couldn't actually make it from inorganic materials, but they showed that you can.
So today, when somebody reads about, oh no, look, they've discovered organic compounds on this other planet, that doesn't necessarily mean it's from life.
No.
Now, organic compounds are found in life.
Absolutely. Compounds found in life will be organic compounds, but they are not necessarily, if you find an organic compound, it's not necessarily found in life. It could have been synthesized.
Gotcha.
Or it could even have been produced in other ways. If it was found in space, that doesn't mean it came from a living thing.
Well, that'll help a lot of people, by the way, I think, because I think there's a lot of people out there that read organic compound and they automatically think life rather than just that's a molecule or a substance.
And of course, the writers of popular science articles get these things confused in that way too. Because carbon can concatenate and join up with other carbon atoms in long chains, there are as many compounds of carbon as there are all other elements put together.
Wow.
So there's an entire branch of chemistry called organic chemistry, which is not necessarily to do with living things.
That is fascinating. Well, Paul, I remember learning about the Miller-Urey experiment in school.
Did you?
And it was a fascinating time. I'm just trying to think back to, man, when was that? How did that work?
Okay, class, listen up. What we're going to be learning about today is how life actually evolved from non-living chemicals in the ocean billions and billions of years ago. You see, all these things happened by chance. We're not going to have any of this nonsense about these things being designed by some sort of god somewhere. We're going to explain how this apparatus proved that life could come from non-living things. The apparatus was designed by a scientist called Stanley Miller, and he was trying to show that amino acids could form from non-living chemicals. So he boiled up some water here. We've got water vapor coming into this flask, an electric current going through. The materials get condensed as they come out of the flask. And in this flask here, you've got the water vapor, you've also got methane, you've got ammonia, maybe a bit of carbon monoxide. What you've got, in fact, here are exactly the same gases as there would have been in the early Earth's atmosphere a few billion years ago. Yes, go on, Mr. Hovind.
Hey, how do they know that those are the gases that were in the original atmosphere?
Well, that's a very good question indeed. And the reason why we know that is if you look at an amino acid molecule, you'll see that there's this amine group here on this side, and that must have come from ammonia. The R represents an alkyl group, some sort of hydrocarbon, so that must have come from something like methane. So that really explains why you would have had to have had ammonia and methane in there.
I got a question.
You have another question?
Yeah. How come there wasn't any oxygen?
Well, the reason why there wasn't any oxygen is that it has to be a reducing atmosphere, you see. Yes, go on.
How come it had to be a reducing atmosphere?
Well, you see, actual element oxygen, O2 molecules, are very, very reactive indeed. We think of them as having a double bond, but actually the bond is a little bit too long for a double bond at 121 picometers. So what happens is you've really got a single bond with some lone electrons on the oxygen atoms. That makes it a di-radical, which is very reactive. It would smash up the amino acid molecule as soon as it was formed. So what happens then is that we've got the electric current going through that mixture, and the amino acids are being made by the reaction in the flask, and the amino acids are then taken out through this chemical trap here. Yes, go on. Another question then.
How come the amino acids couldn't just be left in the circuit and go back through and make like more? Maybe it could have made more amino acids.
Yes, well, you see, it doesn't happen like that, Hovind, because as the mixture gets into the flask, you've got vaporization. That vaporization would also break up the molecules. So that's why you have to take out the amino acids by this chemical trap. So,
I got another question.
Go on. Another question then. Go
on. I was just wondering, you said this happened in the ocean?
Yes.
Is there like a chemical trap in the ocean somewhere that keeps the amino acids from, going back through that whole cycle?
Yes, well, that's a very good question.
Oh, thanks.
Okay, now, what?
Oh, what's the answer?
Well, pay attention, and then you'll probably learn, okay?
Yes, sir.
Yeah. Anyway, the experiment had been running for quite a while, and Stanley Miller found that he'd made lots of amino acids. And amino acids are, of course, the building blocks of life. Yeah, go on, another question.
Yeah, so the experiment formed exactly the right amino acids for life?
Well, not exactly. There were some amino acids made that don't occur in nature, and there are other amino acids that you need that were missing, but hey, they were amino acids, okay? Go on, another question.
Yeah, I'm just trying to figure this out. So you're telling me he made amino acids, but I heard that there's like different kinds of amino acids and only some of which are needed for life. So did he only make those, or what did he really make?
Well, that is true. The amino acids that you make, all amino acids have a property known as chirality. That's a big word, but what it means is you've got this central carbon atom, and arranged around it in space are 4 different groups. That means you can arrange those in 2 possible mirror images. You can see them on this diagram here, the 2 possible mirror images of amino acids. They do the same thing. Every amino acid has these 2 mirror images. They do the same thing apart from the fact that one moves polarized light to the right, the other moves polarized light to the left. This one here in this person's left hand, ironically enough, is the D form, which means the right hand form. And the one here on the right-hand side is the L form, which means the left-hand form. So you've got both those forms, okay? Yeah, go on then.
So the one in the right hand is the left-handed amino acid, and the one in the right hand, or the one in the left hand is the right-handed amino acid?
Yes, that's correct. Yes.
That's weird.
It is. That's unfortunately just the way that they've drawn it.
Okay, so life has both right-handed and left-handed amino acids? Is that what he made?
No, actually, living things have only the L form, this one here. The D form doesn't work, but hey, there were amino acids, okay?
So wouldn't you just have to produce the L form for life? And if you made both, it wouldn't be life?
Well, yes, that's so. And this experiment can be refined so that it does produce just the L form or more of the L form. For example, a stereospecific catalyst could be added so that it's the right shape, so that only the L form can actually form there, okay?
So how did that catalyst get in the ocean?
How did the catalyst get in the ocean?
Yeah.
You know, you ask far too many questions, Hovind. No one likes a smart aleck, you know.
Oh, well, it's Eric, not Alec. But hey, you think this experiment proves that complex organic compounds can form by chance?
Well, yes, of course.
Man, Stanley Miller must be really smart.
Yes, he was. He was a highly intelligent scientist.
So an intelligently designed experiment with carefully built apparatuses like that can produce a random mushy mixture of amino acids, some of which are useful, but most aren't useful for life, and some are kind of missing?
Well, if you put it like that, I suppose so.
Well, I was just thinking that this doesn't prove that life came from random processes after all, like you were saying at the beginning. Even if the experiment had produced a living cell, it seems like it would prove that, well, intelligent design is needed to make life.
You know, you talk far too much, Hovind. Copy out the next 3 pages of your textbook to keep you quiet.
Yes, sir.
Eric.
Hey, man, I remember the desks being bigger back in 5th grade.
What?
The desks, they were a little bit bigger back then.
Eric, stay focused.
Oh. Well, anyway, Miller and Urey, they didn't actually make life, did they?
No, they didn't. What they really proved was that life requires a very intelligent designer.
Yeah, that's exactly right. Okay, so what about the primordial soup? Could the primordial soup have created life another way? We'll talk about that right after this.
Don't miss the boat. contains information for the layman who wants solid evidence of the worldwide flood that he can share with others. Theological considerations, historical essays, and scientific implications are included, as well as fictional representations that convey the emotional power of God's judgment on a wicked pre-flood world. To order Don't Miss the Boat, visit us at creationstore.org.
Welcome back. You're watching the Creation Today show with Paul Taylor and myself, Eric Hovind, and we've been talking about the origin of life. Evolutionists say that life must have evolved at some point because it's here, so it had to come from somewhere.
They reckon it had to come from somewhere.
Did it come from Mars? Were we seeded by aliens? Or did the primordial soup, as they call it, create life here on Earth? So that's what we're talking about in today's show.
You know, they reckon that you can prove that creatures have evolved because some of them are so intelligent you can train them with tricks.
So just because you can train an animal, that proves that they evolved?
They think so. I mean, for example, you can train dogs, you can train dolphins.
Right.
The smallest animal they've done that they reckon that they've trained is the flea, because you've heard of flea circuses, you know, and I have one here. You know, I've got a highly trained flea here. This is, in fact, Bert the flea, and he's highly trained. Just a minute. He's gone. He's escaped. Hold still. Hold still. I can see him. He's there. Just wait. Got him. Oh. Bert the flea. He is a highly trained flea, and he does. Hold on a minute. That's not Bert. Some other flea, that one. There he is. There's Bert the flea. Okay. Now Bert the flea does lots of tricks. Okay. For example, jump. Now you can see that, and we can get him to do 4 somersaults and a reverse pike as well. You ready? That was amazing. Give him a big hand. Oh, poor old Bert. But you know, the mixture of chemicals there in the remains of poor old Bert, who just passed. And that mixture of chemicals is like a primordial soup, isn't it?
That's true. That's what they say. They say that right there could have been brought to life.
Yeah, all we need to do is pass an electric current through it. It's the right chemicals. It's clearly full of organic compounds.
Quick, go stick your finger in an outlet.
I could do that, yeah.
I bet it'll jump. Poor Bert. Yeah, but that really, they really teach that you can take the organic compounds of life, like our smashed Bert there, and you could actually create life from that. Life could evolve out of that.
And of course, it doesn't make sense.
No. In show number 1 of this series, we talked about the frog in the blender. Remember that?
We did, yes. And, there were no frogs actually hurt in that show.
No, and no frogs. It's because
some of them had their feelings.
They had their feelings hurt.
Yeah. Well,
they were no frogs jumped out of the blender though.
No, not
Nothing
at all.
Came out.
Not at all.
I don't know how many people have tried that experiment, but it doesn't ever work. So they really do teach that life evolved out of primordial soup. Matter of fact, I just saw an article on September 13th of 2013 that actually discussed this.
Yeah.
Let me read this to you. The title of the article was New Findings Challenge Assumptions About Origins of Life. It says, before there was life on Earth, there were molecules, a primordial soup. You know, Paul, I've actually even discovered this stuff on the shelf at stores today. Here it is, ladies and gentlemen. The original primordial soup is now available in stores. The only problem is, it takes 4.5 billion years to cook. So you're gonna have to wait a little while to cook that stuff up. But here's what they say. At some point, a few specialized molecules began replicating. This self-replication, scientists agree, kick-started a biochemical process that would lead to the first organism. But exactly how that happened, how those molecules began replicating, has been one of science's enduring mysteries. And I read that and I just laugh. Matter of fact, this last weekend at the church I was at, as I read that, a little 9-year-old started laughing hysterically. The whole church loved it. The 9-year-old goes, "That's stupid." And I look at the kid and I go, "You are smarter than the average scientist today, I just got to tell you."
Absolutely.
A 9-year-old saw the silliness of this. But this really is what they're teaching as scientific fact today, that, hey, possibly we came from this primordial soup.
Yes.
And really, they call us God of the gaps, because they say, well, if you can't understand it, then you just say God did it. And we are scientists and we're looking for the real evidence. And I go, they are evolutionists of the gaps.
They are indeed, yes.
That's all they are. They've got nothing when it comes to, it really is a blind faith.
I've heard evolutionists say this. Professor Richard Dawkins has, for a start. He's in his book, The God Delusion, he talked about a process of evolution that couldn't be understood. And he said, well, one day scientists will discover this. There is a complete inconsistency in the way that they treat the evidence. They very much are evolutionists of the gaps.
They really are.
But where can people go then? Because we talked about the fact that high school students are being taught this. When they understand it with the background, we've had a lot of fun with it and we've had a laugh about it because, let's face it, it is very funny.
And I got to tell you, we've dealt with many questions, especially right here at the beginning of the school year, about kids writing in saying, hey, I'm being taught this. What do I do? So if you have questions, we answer those questions at creationtoday.org. Please feel free to write into us. But you've answered a lot of these questions as well. And this really is a serious topic because there's so many people getting duped into this idea that maybe we've evolved from primordial soup.
It's very important. We want to have answers to these things. We've been doing some articles on our website, just short articles that are going to be useful for people doing high school science, so that you've got some sort of brief answers. If you want to dig into things far more deeply, there are places that we can send you to. One of the best things, obviously, keep tuned to this show, the Creation Today show. Very important. But there's this wonderful book here by our friend Roger Patterson from Answers in Genesis. And Roger used to, like myself, used to be a public school teacher. And this particular book is called Evolution Exposed Biology. He's done a sister book to do with earth science, but we're talking about biology today. He goes through the common high school biology books and he shows where the problems are and shows what the real answers are. High school students need that, really, if you're in public school, so you can get the details. Yeah,
you really should equip yourself with this truth, and I'm sure that's available on Amazon. I'm sure it's available at Answers in Genesis. This is available through the Creation Store, so I really encourage you to get that, read it, study it. Christians, in order to stand up in today's world, you really do have to go the extra mile.
Yes.
You got to do extra work on top of what they're learning, or they're teaching and learning that. You got to learn even more so that you stay up to date with it.
And keep in touch with us. Ask us questions. As we said, questions at creationtoday.org, on Facebook, facebook.com/creationtoday.
Thanks for joining us. You guys have a great week.
Do you need the tools to defend your faith? Visit our websites for up-to-date content. Attend one of our live events. And shop online at creationstore.org. We are Creation Today.